Welcome to the course of Network Security. Today we are going to cover two lectures 9 and 10 in a single video, and the lecture is about hash function. Here is a brief roadmap of today's presentation. We will start from the definition of hash function. After that, we will define cryptographic hash function. We will describe a hash function, we will see some properties or characteristic of a hash function, and finally we will finish this lecture with some application areas where hash function is playing an important role. First, let us see what is a hash function. Actually, a hash function, or sometimes we call it a digest, is a process which will transform a random data into a fixed length data. Okay, so the input is arbitrary and the output is going to be a fixed number of characters. You can say that hash function actually takes a message of arbitrary length and then it creates a message digest of fixed length. So the important point here to remember is that the hash function will take a message as input and the length of the message is going to be variable. It could be of any length, but the output, which is also known as message digest, will be of fixed size or fixed length. The input that we provide to the hash function is actually known as the data or the message, while the output, they are recognized by a different name. For example, you can call the output of a hash function as a message digest, or sometimes we call it a hash value, sometimes simply a code, sometimes hash, sometimes digital fingerprint, and also simply we can call it a digest as well. Different names can be used to represent the output of a hash function. It is important to remember that sometimes we use the word hash to refer to two different things. This word can be used to refer to the hash function, which is a process. So it can be used to refer to the hash function, as well as it can be used to refer to the output, which is the hash value or the digital fingerprint or the code or the message digest. So it can be used in both contexts. A hash may refer to the hash function or it may refer to the message digest or the output. Okay. Now, how the hash function actually works, or what is the basic objective of this hash function in the field of cryptography. As I just mentioned that a hash function will accept a variable length, or you can say block of data. Suppose that block of data is represented by m. So the input to this hash function is m. And then the second point is that it will produce a fixed size hash value or message digest, and that has been represented by small h. There is the hash value, the output. So the output is equal to the input message on which we have applied the hash function. Okay, so you can see here, this is actually the mathematical form of the definition of the hash function. Small h, which actually represent the output or the message digest, is actually equal to the hash function which is applied on the data, on the block of data, on the variable length input that has been represented by m. You can also see diagrammatical representation of the hash function here. Hash function, which is like a process. It accepts a message of arbitrary length. You can see the message has been provided as an input to this function. And then the hash function will actually convert this message to a hash value, and this hash value is also known as message digest or simply digest. You see, it is like a number. this is going to be of fixed length. For any length of message, it will actually generate a fixed size value or message digest. And you see, it is like a compression. Normally, in majority of the cases, this message digest is much more smaller than the message itself. So it actually, compression is also a component. We will not go into the detail of compression, but here compression is also a function, a main responsibility of the hash function. Okay, so this is how actually hash function create a message digest, or how it can convert a plain text, you can say, into ciphertext. It is the plain text and it has been converted into something which is ununderstandable. Okay, the main objective of hash function is to achieve data integrity, or you can say there is an application of the hash function. There are other applications as well, but the most important one is to achieve data integrity, and I'm sure you are pretty much familiar with the term data integrity. Okay, in the context of hash function, data integrity means that if a change to any bit or more than one bits in the message M has been changed, then that change will have a great impact on the output. So by using hash function, we can actually achieve data integrity. Okay, because if somebody change the bits of the message during the transmission, then it will affect the hash value as well. A single bit change in the message will change a large number of bits in the output, in the message digest, in the hash value. Okay, so these were some important point about the hash function. And actually there is a term which we use, and that is known as hashing the data. Actually, the process of applying this hash function to the input data is referred as hashing the data. This process of applying the algorithm, the process, the methodology on converting the message into the hash value or the message digest is simply known as hashing the data. Let us see an example of how hash function work. There are different hash functions available. One of them is known as SHA-256. This too is mistakenly written over here. No, yes, this is SHA-256. Actually, this hash function SHA-256 is basically used to determine or to generate a hash value. So for example, you have the input text hello, and you want to generate a hash value or a message digest for this hello, then it could be like this. Oh, you can complain here, you can ask, you can raise a question that I just mentioned that normally, generally, the message digest or the hash value is much more smaller than the text, than the data, than the input. But here you can see the output is much more larger than the input. But in this particular case, we have considered an input of a very small size, because this is just an example. In normal situation, we have to divide the data into blocks, and the block can contain more characters than that of the output or of the hash value. You can try this example on this website as well. This website has different security algorithms available, and one of them is SHA-256, so you can try it. Just go to this website and then encrypt this hello by selecting the SHA-256 algorithm, and you will see it will generate this output for you. Now if you send this output toward the receiver, then the attackers would have no knowledge about this. This is like a ciphertext. They would not be able to generate or to revert it back into the plain text. Okay, you know it because now this algorithm has been breaked. Okay, so that is why it is available on the website. But in normal situation, we are going to use more sophisticated security algorithm for data integrity. The most recent versions of SHA algorithm, message digest algorithm, and so on. Okay, another concept related with the hash function is cryptographic hash function. The concept is same. The kind of hash function that is needed for security applications. The focus of the cryptographic hash function is on securing the applications, and such concept is referred as cryptographic hash function. And normally they are used to preserve the integrity of a message. Okay, and to achieve the integrity of a message, the input message is passed through an algorithm, and that algorithm is referred as cryptographic hash function. Remember, hash function is a process, is a step-by-step procedure, is an algorithm. And cryptographic hash function is nothing more than a simple hash function, but we actually use it for security applications. For some people, the hash function and cryptographic hash function, they are the same thing because the objectives are the same. Okay, to make security, to make our communications secure. That is the objective. And you can see the diagram is exactly the same thing as we just saw on the previous slide. We have a message or a block of message. Here we can represent it with M, and the total number of bits in this message is represented by L. One thing that is new is the letter P. This figure actually depicts the general operation of a cryptographic hash function. As you can see, we have an input, and that input is padded out. Padded out means it is a process which is known as bit padding, and it is actually the addition of one or more extra bits to a message that is going to be transmitted, or maybe that is going to be stored on a medium. And why we add extra bits to the block of the data? Because to make it according to the standard size. For example, the standard required that the message block must be of 128 bits, and the actual bits of the message are 120. So you need to add 8 extra bit in order to make it compatible with the standard. Those extra bit that you add to the message is known as bit padding. And why we need to keep the length of this field fixed? For security reasons, but we will not go into the details. Several hash algorithms have been designed. Some of them are like message digest family. When I say family, it means that this message digest algorithm has several versions, like MD2, like MD4, like MD5, and so on. So MD stands for message digest. In a similar way, we have secure hash algorithm, SHA family, and the algorithms are SHA-0, SHA-1, 2, etc. And it is actually developed by National Institute of Standard and Technology, which is known as NIST. And these two are very famous, very popular cryptographic hash functions. But beside from these two, we also have some other types of hash algorithms. Okay, so coming back to the figure, what you see that we are providing a message having L bits, and the bits have been padded, and it is provided as an input to the hash function. In this case, the hash function is cryptographic hash function. The objective is the same. It will produce a fixed length hash value that has been represented by small h. And then this hash value is normally, in most of the cases, it is going to be much more smaller than the message itself. Let us see another practical example of the cryptographic hash function. What you see here is self-explanatory. We have a client, we have a server. And normally the server provides services to the client, and client avail the services provided by the server. Okay, in this case, the client want to download a file from this server. Before the server sends out the file, it first obtain a hash or a hash value or a message digest of that file. So the server has to use an algorithm of cryptographic hash function. SHA-1, as I just mentioned, SHA is a family of hash function, and 2 is the version. Suppose the server is using SHA-2 algorithm, so it will compute the hash value of that file. Okay, and then the server send the hash, which is also known as message digest, along with the file. So actually, we are sending two things: the file and the hash value. Upon receiving the two files, the two items, there is the downloaded file and the hash file, the client will obtain the SHA-2. The client is actually using the same algorithm, SHA-2. So the client first will download the file and then will apply the algorithm and will compare the hash value with the hash value sent by the server. If these two hash values are same, then the client will accept the file, which means the integrity of the file has been maintained. If these two values matches, then it means that the file was not tampered, not changed, not altered during transmission along the way. But if the computed value is different from the generated value, suppose now these two values are not equal, then this is an alarming situation for the client, that during transmission the file has been changed. Now, description of a hash function, it is simple. It shows us how actually a hash function works. So as I just mentioned, the hash function will accept an input data message block. It will divide the message, the input, the data into blocks of fixed size. And then the hash for the first block, or the message digest for the first block, will be calculated, and then the hash for the second block will be calculated, and then the third block, and so on. Normally in this case we just consider a single hash, a single block of the message, but in reality, in practical world, we would be dealing with much more blocks of data. And then for more security, we have to provide the output of this first block as an input to the second block, and then the output of this second block will be provided as an input to the third block, and so on. So it is like a chain of output. The output of the previous step is provided as an input to the next step. Okay, so it is like linkages. They are linked with one another to achieve more secure hash function. And this process is repeated until all the blocks are being passed from the hash function. Now, some desirable properties of a hash function. How you will decide that a hash function is secure? For that, we need to, any hash function that actually satisfy these properties, we can say that it is more secure as compared to other hash functions available. Some of these properties are: the first property is that you can apply the hash function on any type of digital content, on any format. So you can play it on digital content of any size and any format. All type of digital contents can be made secure, like text, like images, like videos, like numbers, and so on. because you know computer deals only with numbers, so everything for the computer is 0 and 1. Second property is that your hash function must produce the hash value, the message digest, in a simple way. Okay, it means that for any message M, it is going to be relatively easy to compute the message digest, or to convert. It could be very easy to convert the input message into a hash value. It means that it can't make a lot of processing time or processing capabilities to compute the hash, to compute the message digest. It is going to be a simple task, a simple process. Conversion of plain text into ciphertext, for example, by using hash function is going to be a simple task. And also, as we just saw, the output of any hash function must be of fixed size. Input may vary, but the output is going to be of fixed length, and that has been represented by h, small h. So for any message, the output is going to be of fixed length. Any given input may produce a fixed size, in most cases numerical output. And also the output is going to be deterministic. That is, the same input message or data will always yield, always produce the same output. This is not a good property from security point of view if every time the message, input message is generating the same hash value. From security point of view, there is not good point. But the algorithm is like this, that it will always yield the same output. This property is actually interesting. Little changes in the message produces a different hash. If you change even a single bit in the input data, then it will have a great impact on the hash value itself, or on the message digest, or on the output. It will produce a completely different output. And there is the beauty. It will make sure that nothing has gone wrong during transmission of the data, because if something goes wrong, then the output will be affected. So a minimum variation in the original message, for example, 1 bit must yield a completely different hash. And this property sometimes is known as diffusion. Okay, there is a special name for this property that is called diffusion. Okay, next property is that, for example, if you have a message that has been represented by capital M, so it is going to be hard to find another message like M dash, for example, such that the hash of both the message is same or is equal. Okay, this property is very important. It says that you have an input message which is given, that is M, and you are trying to find another message, for example M dash, that will create the same message digest, or that will create the same hash value. That is impossible, or maybe extremely difficult if not impossible. And this property is known as weak collision resistance. If a hash function satisfies this property, then we can say that it is weak collision resistance. It resists weak collision. And it is impossible that you will find another message that will actually generate the same hash value. Last property. It is difficult to find any two messages that will actually hash to the same value. Now this is something related with the previous property. For some people it seems like they are the same thing, but they are not the same thing. We will see in a moment. But first let us see the last property, what it says. According to the last property, it is going to be extremely difficult to find any two messages that will actually hash to the same value. You can say that it is hard to find M1 and M2 such that both will generate the same hash value. In the previous property, we were talking about a single M. Here in the last property, we are talking about 2M. It is hard to find M1 and M2 such that the hash value of both the messages will be same. In simple word, you can say that finding any two messages that will yield the same summary or hash value will be extremely difficult, if not impossible. And this property is known as strong collision resistance. So we studied three important properties. The first one was about the diffusion, and then we saw the property of weak collision resistance, and then finally the strong collision resistance. Now let us see the difference between these two. This figure, I'm sure, will make things clear. I didn't mention which one is the strong one and which one is the weak one, and we also have the third one, and this property is actually known as pre-image resistance. Okay, so you have to work on this figure. You have to figure out from this figure which one is pre-image resistance, which one is weak collision resistance, and which one is strong collision resistance. Okay, for pre-image resistance, let me tell you that if you have given a hash value, so it is going to be infeasible to generate a message from that hash value. And we saw it in cryptography as well. If the ciphertext is given, then that is impossible to derive the plain text from that. So there is the same thing. If the hash value is given, then it is almost impossible to derive the message from that hash value. And such property is known as pre-image resistance. Rest of the things you have to explore. So the difference between these last two properties. Actually, weak collision resistance is bound to a particular input, whereas on the other side, the strong collision resistance applies to any two arbitrary inputs. As the name implies, it is more difficult to achieve strong collision resistance. On the other side, weak collision resistance is a bit simpler as compared to the strong collision resistance, because strong collision resistance implies a weak collision resistance, but weak collision on the other side does not imply strong collision resistance. Means if an algorithm is comply to strong collision, then obviously it satisfies the weak collision. But if an algorithm satisfy the weak collision resistance, is not necessary that the algorithm will also meet the requirement of the strong collision resistance. So it is a bit technical. Well, now see applications of the hash function. We can use hash function for different for different functionalities. We can achieve different security levels by using hash function. The first one is known as message authentication. So hash function is widely used for message authentication. And authentication, you know very well what authentication is. And message authentication means, yes, you're right. So we have covered this topic in the start weeks of this course. So message authentication, as if you revise the concept, it is actually a security mechanism or security service that is used to verify the integrity of a message. And integrity means nothing wrong happens to the message. Bits are not changed. So message authentication assures that data received is exactly the same as it was sent. It contains no modification, no insertion, no deletion, no replay attack, etc. When a hash function is used to provide message authentication, the hash function value is often referred to as message digest, as we just saw. The output is message digest. Okay. How we can apply hash function or how we can achieve message authentication by using hash function, let us see things in a diagrammatical way. The sender, in this case Alice, and the receiver in this case is Bob. Alice want to send a message to Bob. So the sender will first compute a hash value as a function of the bits in the message, in the data. Okay. And then the sender Alice will transmit both the hash value and the message. So two things. You can see we have the actual data, and then we pass the data to the hash function represented by h here. This is the hash function. It will convert this data into a fixed size output, which is known as hash value. And then she will send these two items, the data and the hash value, towards the receiver, which in this case is Bob. The receiver will perform the same hash calculation on the message bits. And as I just mentioned, the receiver will compare the hash generated from this function with the hash that was sent with the message by the Alice. If the hash values matches with one another, if the generated hash is same as the sent hash, then it means that the message is authentic. If there is a mismatch, for example, the receiver will come to know that the message or maybe the hash value has been changed during transmission. So the concept is clear. We can use hash function for message authentication, mean integrity check, and it helps the user to detect any changes made to the original file during transmission. But remember, it does not provide any assurance about originality of the message. The attacker, instead of modifying the data, the attacker can change the entire file and then will compute a new hash and will send the new file and the new hash to the receiver. This integrity check application is useful only if the user is sure about the originality of the file, because it will not resist an attack against the originality of the file. Okay, so let me repeat this. We can use hash function for message authentication. Actually, here we need to send two things, the original data as well as the hash value. And then at the receiver side, the receiver will actually apply the same hash algorithm on the data that he or she received, and he will generate the hash value. After that, the receiver will compare the hash value generated with the hash value received. If both the hash values are the same, it assures that the message is authentic. Nobody has changed the contents of the message. But remember, it will not assure message originality. To elaborate this concept further, we have a second scenario here. In this case, you can see. So our requirement is that we need a way by using which we can actually transmit the hash function in a secure way. So the hash function must be protected so that an adversary and attacker cannot alter or replace the message. So in this type of attack, Alice transmit a data block as she does before. It is the same thing. But this time we have an attacker, Dirt, the dirty guy in between. Dirt intercepts the message, alter or fully replace the data block, calculate a new hash value and attach the new hash value with the data. Bob receives the altered data with the new hash value and does not detect the change. Okay, so to prevent this type of attack, the hash value generated by Alice, we need to protect this value as well. How we can actually protect this value, we will see later on. We can use a private key here to protect this, maybe public or private key to protect this hash value. But there is a topic for a later discussion. At this moment, you need to make sure that message authentication is possible, but message originality attack is still allowable on hash functions. We can protect them with other techniques, and we will study them later on. Second application of hash function is related with the password, and the concept is known as password hashing. If the system store, for example, your password in unencrypted form, in clear form, then anyone will access to the system storage or the backup tapes can steal the password because they are in plain text. So instead of storing the password in plain text, the system can generate a hash of the password, and then the hash value is stored on the disk. Suppose a user supply a password, then the system will compute the password hash and will compare it with the stored value. If the hash password file is obtained by the attacker, then is not useful for the attacker because the password can't be derived from the hashes. The process is not reverse. Our password are in encrypted form, hash values. So there is useless for the attacker to obtain the password or the plain text from those hash value. In simple words, in simple terms, when a user enters a password, the hash value of that password is stored. And next time when you want to enter into the system, then the hash value of the password is generated and it is compared with the stored hash value for verification. The process is also depicted in this picture. You can see we have in order to get login, we require two things: identity and password. Identity is represented by ID, password is represented by P, and the credentials are stored in a table. So you can see here in the table we have the ID and the password is stored in the form of a hash value. So every time you enter your password, a hash function is applied, a hash value is generated, and that hash value is compared with the stored hash value in the system. If both the generated hash values are same, then access is granted. If they are not the same, then the access is denied. This is the second application. We can also use hash function for digital signatures. Digital signature is a completely new topic and we will cover it in coming weeks. But for the moment, it is actually similar to message authentication application, but in case of the digital signature, the hash value of a message is further encrypted by user private key. So anyone who knows the user public key can verify the integrity of the message. Remember in the previous lecture I told you that normally we use public key for encryption and private key for decryption, but we can reverse the usage of the keys. So here you can see for digital signature, later on we will see that we will be using the user private key for encryption and the user public key to verify the integrity of the message that is associated with the digital signature. More about digital signature in the coming weeks. And beside from that, we also have some other applications. For example, we can use hash function for intrusion detection and for virus detection systems. We can also use it for storage of files on a system, okay, with the help of secure hash values. You can also use it for storing file on a CD, writer or tapes, etc. You can also use the cryptographic hash function for pseudo-random functions or pseudo number generation. They are used normally in simulations, but we will not go into the details. And we can also use it for the generation of symmetric keys. Remember, one of the key challenge in the private key or single key cryptography is how we can actually share and generate the keys that is shared by the two parties. So we can use the hash function for that purpose as well. Thank you so much for watching the lecture. See you and goodbye.